Today we are starting complex numbers. Now what a complex number is it is a real number plus an imaginary number. So first, let's talk about what an imaginary number is. We know that the square root of a negative number is not rational. So we represent this by I, meaning it has an imaginary solution. So if I is equal to the square root of -1, if I square that cancels my radical and we're left with -1. So I squared is -1. And those are going to be the two guiding terms for today as we're doing these operations and simplifying expressions. Now, when we're writing our complex numbers, we always are going to write them in standard form where our real number comes first and our imaginary number comes second. Okay? So, when we have an expression like this, the first thing we want to do is rewrite it in terms of I. If I have the square root of a negative number, I can rewrite that as the square root of that positive coefficient with I behind it. So I is not under the radical. So to rewrite the square root of -4, that would be the square root of +4 times I. Now I know the square root of 4 is 2, so this is going to be 2I. And that is how I write that in terms of I and simplify. So let's do that again. This is going to be the square root of 4 over 25, I. And the square root of 4 over 25 is 2 over 5. So 2/5 I. All right. On C, again, anytime you see a negative inside the radical, what you're going to want to do is rewrite that in terms of I and then simplify from there. Square root of 49 is 7. Square root of 9 is 3. And the square root of 36 is 6. Now, similar if I had 7x minus 3x plus 6x, these are like terms that can be combined. So 7 minus 3 plus 6 is 10, so that is 10I. All right, once again, rewrite this in terms of I. So square root of 25 is 5. And 50 is not a perfect square, so quick refresher on simplifying radicals. I look for a factor that is a perfect square, and for 50 that would be 25. So 25 times 2 are what multiply together to give me 50. The square root of 25 is 5, so that can come out, and the 2 has to stay inside the radical. So that square root of 50 simplifies to 5 square root of 2. Now I have a 5 in the top and the bottom, so that cancels, and I have an I in the top and the bottom, so I'm left with 1 over the square root of 2. Now we don't like having radicals in the denominator, so we're going to rationalize it, and that leaves us with a final answer of square root of 2 over 2 on example D. Now, this is all operations and combining our like terms, and anytime that we get a term that has both real and imaginary numbers, we need to make sure we're writing our answer in standard form. So on this first one, I don't have any multiplication or distribution going on. I'm just going to be combining my like terms. So I'm going to rewrite this without my parentheses. And my real numbers are 4 and -6, so that combines to -2. And my imaginary numbers are -3i plus 8i, and that leaves me with 5i. So again, standard form, real number in the front, imaginary number in the back. Now on F, I'm multiplying binomial, so I'm going to have to FOIL. So 6 times 6 leaves me with 36. 6 times minus I times 6. And then I times -I gives me minus I squared. So I've got that 36, and those middle two terms cancel. Now I have minus I squared. Recall, we already talked about on the front that I squared is equal to -1. So this is 36 minus -1. Now minus a negative is plus positive, so the final answer on F is 37. So anytime we have an I squared, we're going to want to substitute in that -1 and then combine whatever terms we can. Moving on to G, I'm going to have to FOIL again. So I get 16 minus 40i. And then 3i times 2 is 6i. 3i minus 5i is 15i squared. So now, again, combining our like terms, we've got that 16 still in the front. Negative 40i plus 6i leaves us with negative 34i. And remember, I squared equals -1, so this is -15 times -1. So that gives us +15. So combine my real numbers, and that gets us a grand total of 31 minus 34i. Again, real number in the front, followed by our imaginary number. Now on H, we don't have to FOIL or distribute, but if I'm going to combine my like terms, I need to get this into I form. So remember, I can rewrite this as the square root of 8i. And 8 is not a perfect square, so I need to look for factors of 8 that are, and that would be 4. So 4 times 2, I can take out the square root of 4. And that's going to leave me with -2 square root of 2i. So I can combine my real numbers, 6 and 2, and that's going to give me 8. Now 3 and 2 square root of 2 I can't combine. So what I'm going to do is factor out the I from both terms and just leave that as the difference of my coefficients. Right. I am squaring a binomial, which means I have to FOIL, so I'm going to rewrite it so I can keep track of all my steps. 3 times 3 is 9, 3 times 2i is 6i, 2 times 3i is 6i, 2i times 2i, 4i squared. So 9 plus 12i, and then this is 4 times -1, which is -4. So 9 minus 4 leaves us with 5. Okay, now J and K are a different kind of animal. What we have here essentially, remember I is equal to the square root of -1. So I have a radical in my denominator, and we don't like having radicals in our denominator. So we want to essentially rationalize it. So what we need to do is multiply by what we call the complex conjugate, and that's just a really complicated word to say we're switching the operation between the two terms. So in the bottom I have 7 minus 6i, so instead of minus I am going to add. That is my complex conjugate. You're just switching the operation in between. So we're going to multiply by that conjugate on the top and the bottom. Okay, so now I need to distribute that 12i to the 7 and the 6i. So that's going to give me 84i plus 72i squared. And in the bottom we have to FOIL. So we're going to get 49 plus 42i minus 42i minus 36i squared. So now let's simplify and combine our like terms. That 84i is going to stay the same. 72 times I squared is minus 72. In the bottom, my middle terms cancel. I've got 49. Negative 36 times I squared is positive 36. So again, in the top I have a complex number, and I want my real number in the front. So I'm going to rewrite that as 72 plus 84i. Sorry, negative 72 plus 84i. And then in the bottom, I'm going to combine 49 and 36 to get a grand total of 85. Now, 72, 84, and 85 don't have common factors, so I can't simplify this further. Now, how do I rationalize an expression like this when I don't have an operator in the bottom? So this is not being added or subtracted from anything. So what we're going to do is multiply by I in the top and the bottom. So we distribute to the 9 and the I, and then in the bottom we have 5i squared. So let's simplify. This gives us 9 minus -1 over 5 times -1. Sorry, that's 9i. So that's going to be 9i plus 1 over -5. And I need to rewrite this in standard form. So 1 plus 9i over -5. All right. Now, if we want two complex numbers to be equal, meaning they have the same value, that means that their real number and their imaginary number have to match. So the real number needs to be the same, and the coefficient on our imaginary number needs to be the same. So looking at example L here, 3 is my real number on the left side, which means that my real number on the right side, A, has to match. So if A is 3, then the real numbers match. And then on the left side, the coefficient on my imaginary number is -4. So if it's going to match on the right side, then b has to be equal to that coefficient of -4. So that's an easier example. Let's see what happens when it gets a little more complex. So on the right side of m, my real number is 5. So for this to match, a plus 3 has to be equal to 5. So if I subtract 3 on both sides, I find that a is 2. And that allows my real number to match on the left and the right. Now I need my coefficient on my imaginary numbers to match. So -4 and b minus 1. So b minus 1 has to equal -4. So if I add 1 to both sides, I find that b is -3, and that will make my imaginary numbers match. Okay. Next one, we want to verify that this is a solution of our quadratic here. So what we're going to do is plug in this value into x in here and here, so in both places. So that's going to be -1 plus 2i squared plus 2 times -1 plus 2i plus 5 equals 0. Now this is squaring a binomial, so we're going to have to FOIL, so I'm going to rewrite it expanded so that I can keep track of that. And now let's FOIL and distribute and combine our like terms. 1 times 1, -1 times -1 gives me +1. That gives me -2i minus 2i plus 4i squared. Then I distribute this 2, and I get -2 plus 4i, and then that 5 on the end stays where it is. So now let's combine our like terms. So far with my constants, I have +1, -2, and +5. That's going to give me 4. Then with my I terms, I have -2i plus 4i, and those are all going to cancel. Then I have this 4i squared term, and that is 4 times -1. So that's going to be 4 minus 4, which is 0. So this is a possible solution. And I'm running out of time, so I am going to do the last part on a different video.